Hello everybody, getting ready to do lesson 8.3 part 1 of pre-calculus math today. And for 8.3 part 1, geometric sequences and series, you got 8 points here in your notebook, and then you'll have 56 points on your classwork sheet. Students, put your name, date, period in my classroom. If you're online or you're homeschooling, put your due date here. And then let's go into our bell work for today. Students, teachers, we have a word problem here. A truck traveled at an average speed of 50 miles per hour on a 2-mile trip. On the return trip, the average speed was 42 miles per hour. Find the average speed for the round trip. Give your students 6 minutes. Teachers, see you back in 6. Okay, welcome back for your solutions. Today's bell work, nice little word problem here. So for our time, we have distance over speed will give us 200 miles and 50 miles per hour here, plus 200 miles at 42 miles per hour. On the return trip, the average speed is 42 miles per hour. 200 over 42 equals 200 times 92 over 2100 hours. So here's our time that's drawn together from those two. And then when we have our speed here, distance over time equals 400 when we add these together. And then when we solve here, we have 200 multiplying by 92 divided by 2100. And this gives us 2 over 2100 over 92 will give us an average speed here 45.65 miles per hour. This is using a lot of linear programming here and using a lot of different kinds of quotients here to come up with this. There are simpler ways, but this is definitely a fancy way of finding your average speed for the round trip. Okay, page 1, geometric sequences. In 8.2, you learned that a sequence whose consecutive terms have a common difference is an arithmetic sequence. In this section, you will study another important type of sequence called a geometric sequence. Consecutive terms of a geometric sequence have a common ratio. Definition of a geometric sequence. A sequence is geometric when the ratios of consecutive terms are the same. So the sequence a1, 2, 3, 4, and a to the n is geometric when there is a number r such that a2 over 1 equals a3 over 2, a4 over 3 will equal r, and where r cannot equal 0. The number r is the common ratio of the sequence. So let's try one now. Examples of geometric sequence. A, the sequence whose nth term is 2 to the n is geometric. So for this sequence, the common ratio between consecutive terms will be 2 here, 2 to the n. 2, 4, 8, 16, and 2 to the n begin with n equals 1. So n would equal 1, and you go on here. B, the sequence whose nth term is 4 times 3 to the n is geometric. So for that one, for this sequence, the common ratio between consecutive terms is 3. Here is our 3 there. So each one of these has a factor of 3, beginning with n equals 1. And then for C, the sequence whose nth term is negative 1 over 3n is geometric. For this sequence, the common ratio between terms is negative 1/3. So here we have negative 1/3 between each one of these, beginning with n equals 1, where our ratio here, our common ratio, is negative 1/3 between these. So let's try one here. Determine whether or not the sequence is geometric. If it is, find a common ratio. Okay, so our solution here, determine whether or not the sequence is geometric. If it is, find a common ratio. What's your common ratio here, students? And down here, this is yours. What's your common ratio down there? So for this one up here, not a geometric sequence because it is an arithmetic sequence with d equals 12. You have a difference here of 12. You don't have a common ratio between these numbers. And down here, that's you, students. So moving on to page 4 of our lesson here. The sequence 1, 4, 9, and 16, whose nth term is n squared, is not geometric. The ratio of the second term to the first term is a over 2 over a over 1 equals 4 over 1, which equals 4. But the ratio of the third term to the second term is 9 over 4. So these are not the same ratio here. So they're not geometric. The nth term of a geometric sequence, has the form of a to n equals a1 r to the n minus 1, where r is the common ratio. Here's your common ratio of consecutive terms of the sequence. So every geometric sequence can be written in the following form. So we have a1, a1r, a1r2, a1r3, a1r4, and out to a1r to the n minus 1. So if you notice here, this is a1, so a1r, a1r2, so we start here at a1 without an r. That's why you have your n minus 1 here. Okay? And oh, by the way, when you know the nth term of a geometric sequence, you can find the n plus 1th term by multiplying by r. That is a to the n plus 1 equals a to the nr. So say what? Well, let's get examples that show that. Finding the terms of a geometric sequence, and the first 5 terms of the geometric sequence whose first term is a to the 1 equals 3, and whose common ratio is r equals 2, starting with 3, repeatedly multiplying by 2 to obtain the following. So a1 equals 3 is your first term, and then a2 would be 3 times 2 to the 1 would equal 6. So that's your second term there. And then your third term here would be a3 would equal 3 times 2 to the second power equals 12. And then a to the 4 would be 3 times 2 cubed would be 24. So that would be the way that you would write these geometric sequences. So a to the 5th would be 3 times 2 to the 4th would equal 48. So this is your n minus 1 here. This is actually your 5th term, but it's to the n minus 1 power. So let's try one here. Write the first 5 terms of the geometric sequence here. We have a1 equals 6, and then we have r equals 6. Okay, so moving into our guided practice here. Write the first 5 terms of the geometric sequence, and we have a1 equals 6, and then our rate here equals 3. So since we know that a1 equals 6, rate equals 3, our a2 here will be 6 times 3 to the first power will be 18. And then over here, our next output here will be it'll be 3 squared times 6 will be 54. Or if you do it in a recursive manner, it'll be 3 times 18 will be 54. And then 3 cubed times 6 will be 3 cubed would be 27 times 6 will be 162, or you just go 3 times 4 will be 162. And then our 5th output here will be 3 to the 4th power, which is 3 times 3 is 27, so it'll be 81 times 6 will be 486. That'd be another way, or you could just go 3 times 162 will be 486. So that'd be the way you would solve that. And students, this one's on you, so give that a shot. Moving into our next example here. Finding a term of a geometric sequence. Find the 15th term of a geometric sequence whose first term is 20, A1 would be 20, and whose common ratio is 1.05, or R equals 1.05. So again, here's our formula. Formula for a geometric sequence, A1. So you find the 15th term. Well, we only know the 15th. We don't know what A1 is, do we? And who's, oh, we do. So if A1 here is 20, so you know 20 will go here, and our ratio is 1.05. That'll go here for R. So we do know that much. So when we plug in 20 times 1.05, and we're trying to find the 15th term. So N will be 15 minus 1. And then when we put that into our calculator, 20 times 1.05 to the 14th power, you should get 39.60. And then for this sequence, R equals 1.05, A1 equals 20. So A to the N would equal 20 times 1.05 to the N minus 1. That's our general formula. And then use the table feature of your graphing calculator. When you put this into your graphing calculator, N and N here, use the table feature of your graphing calculator to create a table that shows the terms of the sequence as shown. And then your 15th row here, 15th term of the sequence would be 39.60. So that'd be a way that you could check, just to be triple sure that this is the correct response here. So let's try one in our guide practice. Find an indicated term. So we find a 12th term here of the geometric sequence A, using, here's our A here, using the table feature of a graphing calculator, and B, algebraically. So we have graphing and then algebraically. Students down here, for your independent practice, this is your graphing, this is your screenshot on your graphing calculator, and then this is your algebraic proof to find your 8th term. But let's stay up here. So we need to find our 12th term with these with those conditions there. So here's our formula: A to the N equals A1 R to the N minus 1. And then when we plug in A to the 12, so our 12th term, we need to find A to 12. We know A to the 1 would be 6. And then our ratio here is 1/3, and then we go 12 to the minus 1. And then when we crank out 6 times 1/3 to the 11th power, we get this number here. And then your algebraic proof here would be basically this here, 6 times 1/3 to the 11th power will be this number here. And then you come up with this fraction, 2/59,049. So, all right. And then down here, students, you just do the same from this kind of modeling up here. And let's go into our next example here. Finding a term of a geometric sequence. Find a formula for the nth term of the following geometric sequence. What is the 9th term of the sequence? So here is our sequence. The common ratio of this sequence will be 3, so we have 15/3. Because the first term A1 is 5, which is there, the formula must have the form of this. So A to the N would equal A1 R to the N minus 1, and then we plug in what we know here. 5 is our A1, and then our R is 3 to the N minus 1. So here is our formula for this sequence here. And what do we want to do with that? So you can determine the 9th term, N equals 9, to be A to the 9 will equal 5 times 3 to the 9 minus 1. Substitute 9 for N. And then when we crank this out, we got 5 times 65, 61. And that comes out to 32,805. So that would be your solution. So, okay, so a graph of the first 9 terms of sequences here. Here's our graph here. We got plots here. And then here is our ninth term up there. So notice that the points lie on an exponential curve. So I think there's a curve that goes something like that. This makes sense because an is an exponential function of n. So this geometric sequence is an exponential. So let's try one now. Find a formula for the nth term of the geometric sequence. So we want to find a ninth term of this sequence, and then down here for you students, we want to find a seventh term for this sequence here. But for up here, what do we do with this? So r equals 3, 21 divided by 7 is 3, and then a to the n will equal 7 times 3 to the n minus 1, and we want to find a ninth term, so we go a to the 9, I'm sorry, will equal 7 times 3 to the 9 minus 1, which comes out to this number here. So that is your 8.3 Part 1 Pre-Calculus Math classwork lesson. Here's my email, animatedpowerpointmathvideo@aol.com, for homework sheets, note-taking sheets, classwork sheets, solution PowerPoints, you name it. Email me there and I'll get back to you. Thank you very much.